Top 1. The Moulagi Neanderthal Butchery. Along the Rhône Valley in southeastern France, overlooking the Ardèche River, there is a limestone cave called Moulaghersy. Today it is unremarkable, a shadow in the rock face, easy to walk past and easy to ignore. However, 100,000 years ago, during the last interglacial period known as the Eemian, this cave was occupied not by our species, but by something older. These beings hunted, made tools, cared for their injured, and as the bones inside would eventually tell us, ate their own kind. In 1999, paleoanthropologist Albin de Fleur and his team published their findings in the journal Science after years of excavation at the site. What they recovered from a single stratigraphic layer designated level 15 were the fragmented remains of at least 6 Neanderthal individuals, 2 adults, 2 adolescents, and 2 children. Found alongside them in the same deposit were the butchered bones of red deer. The processing marks on the Neanderthal bones were identical to those on the deer. Identical cut marks from stone tools clustered at muscle attachment sites. Percussion fractures were found along the shafts of long bones, the kind produced specifically to crack bone open and extract the marrow inside. Disarticulation marks were present at the joints. Shoulders, hips, and knees were separated, worked through in a methodical and efficient sequence. Tongues had been removed and skulls had been opened. The cranial fragments showed percussion patterns consistent with accessing the brain. This was not scavenging. The cuts were too deliberate and too anatomically informed. This was not an animal gnawing at an abandoned carcass in the dark. These were tool marks made by hands following a butchery sequence, the same sequence applied to prey. One of the individuals processed this way was a child whose femur was cracked lengthwise to extract the marrow. The stratigraphic context is not in dispute. Faunal remains, pollen analysis, and sediment composition all independently place level 15 within the Eemian interglacial, approximately 100,000 years before the present. This is not a disturbed or contaminated deposit. The Neanderthal remains and the deer remains were processed in the same location at the same time by the same hands. De Fleur and his colleagues interpreted the evidence as nutritional cannibalism. Neanderthals consuming other Neanderthals for caloric reasons, most likely during a period of resource stress. Tim White, who had previously documented similar cut mark patterns at the Neanderthal site of Krapina in Croatia, noted that Moulaghersy represented the clearest and most methodologically rigorous case for Neanderthal cannibalism yet assembled. The pattern, he argued, was not explainable away. There is a rebuttal, however. Some researchers sympathetic to a more complex picture of Neanderthal cognition have raised the possibility of mortuary cannibalism, the ritual consumption of the dead practiced as a form of respect or grief, documented in certain modern human cultures. They argue the bone processing at Moulaghersy cannot tell us the motive. De Fleur's team stands by the nutritional interpretation, pointing to the complete absence of any burial, the systematic marrow extraction, and the direct behavioral parallels to food-animal processing occurring in the same layer. And then there is the reading no one states plainly. The 6 individuals recovered from level 15 were not found dead and then processed out of grief or ceremony. The efficiency of the butchery, the targeting of the most calorie-dense tissues like marrow, brain, and tongue, the inclusion of children, and the total absence of anything resembling ritual treatment suggest otherwise. Some researchers have noted quietly that if these remains belonged to any other species, we would have no hesitation calling it predation. The only reason we pause is because the bones look like ours. 6 Neanderthals processed like deer in a cave above the Ardèche River 100,000 years ago. Tongues removed, marrow extracted, children included, and not a single body buried. That is the oldest unambiguous evidence of one human species consuming another. Top 2, the Naturuk massacre. Being consumed by your own kind is not the oldest indignity in the human story. For that, we have to go further back to the Naturuk massacre. Naturuk is a dry lake bed on the western shore of Lake Turkana in northern Kenya. It has been under systematic analysis since 2012 by Marta Mirazon-Lar of the Leverhulme Center for Human Evolutionary Studies at Cambridge University, later supported by Robert Foley, a leading figure in the study of human behavioral evolution in prehistoric conflict. The evidence of mass violence comes from a single undisturbed sediment layer dated to approximately 9,000 to 10,000 years ago, placing the event in the early Holocene. 27 skeletal remains were recovered, representing a minimum of 12 adults, one adolescent, and several children, including a woman in the late stages of pregnancy, identifiable by fetal bones still positioned within her pelvis. Every recoverable skull showed trauma. Only the smallest peripheral bones, like fingers and toes, survived intact and unmodified. That pattern is consistent with targeted close-range interpersonal violence, rather than accidental death or environmental collapse. The wound evidence is systematic and varied. Blunt force trauma had caved in the frontal and parietal bones of multiple individuals. Obsidian and chert projectile tips were found embedded directly in skull fragments and lodged in the thoracic cavity of one male. The hands of at least two individuals showed fracture patterns at the wrist consistent with binding, suggesting they were restrained before death. One male had four distinct injury types recorded on a single skeleton: blunt trauma to the head, projectile penetration to the knee, fractured cervical vertebrae, and broken hands. That skeleton is the most important one because it doesn't describe a skirmish or an accident, it describes an execution. Each injury type requires a different weapon, a different angle, and a different moment. Someone stood over that man more than once. Marta Mirazon-Lar stated the site represents the earliest scientifically documented evidence of lethal intergroup conflict in the prehistoric record. The study was published in Nature on January 20, 2016, and is considered the most complete forensic case for organized prehistoric warfare ever assembled from a single site. Lar and Foley's analysis argued the massacre likely occurred during a period of resource compression around a critical freshwater source. Lake Turkana's shoreline was contracting, and hunter-gatherer groups dependent on the same water and prey corridor would have been pushed into direct competition. Their proposal is that a rival group launched a coordinated attack, not a raid but an elimination targeting all age and sex categories without selection. The counter-argument raised by several paleoanthropologists holds that 27 individuals is too small a sample to extrapolate organized warfare. The site could represent a single violent encounter between two small bands, not evidence of systemic conflict. However, the presence of bound individuals, multiple weapon types, and the deliberate killing of a pregnant woman and children, combined with the complete absence of defensive injuries on the victims, makes the ambush and execution interpretation dominant. The most disturbing reading is that the attack was not opportunistic, but demographic. No age group was spared. No individual shows wounds consistent with flight or resistance, only with being struck while stationary or restrained. The massacre may not have been an escalation of conflict, but the intended conclusion of it. A pregnant woman, several children, an adolescent, and 12 adults were projectiled, bludgeoned, bound, and left face down in the sediment beside a shrinking lake. That forensic picture is complete, and the organized group responsible for it was operating with a level of coordinated lethal intent that would not look out of place 10,000 years later. Top 3, the 1.45-million-year-old butchered shin bone. The Turkana Basin, specifically the Kubifora Formation, is part of a fossil-rich sedimentary landscape along the eastern shore of Lake Turkana in northern Kenya. First systematically surveyed in the late 1960s under Richard Leakey, the modern analysis of a cut-marked tibia fragment was led by Brianna Pobiner of the Smithsonian Institution's Human Origins Program and published in 2021 in Scientific Reports. It established the oldest direct evidence of hominin-on-hominin butchery ever recorded. The tibia fragment has been dated to approximately 1.45 million years ago, placing it squarely in the heart of the early Pleistocene, a period when multiple hominin species overlapped across the same landscapes, competing for the same resources before only one lineage survived. The specimen is a partial left tibia cataloged as KNMER741, recovered from surface deposits at Kubifora. The cut marks are extensive, 11 distinct linear incisions clustered in two separate regions of the bone shaft. The mark morphology matches stone-tooled defleshing, identical in pattern and depth to cut marks found on large mammal bones processed for food at the same stratigraphic levels. But this bone has something that stops the analysis cold. The cut marks are not random. They are placed precisely where the largest muscle groups of the lower leg attach, such as the gastrocnemius and the soleus. These were not accidental contact marks from butchering a nearby animal. Something targeted this hominin's leg for the specific purpose of removing flesh. Prior to this specimen, the oldest proposed evidence of hominin cannibalism or interspecies butchery came from sites roughly 600,000 years younger. The Grandolina site at Atapuerca in Spain, dated to approximately 800,000 years ago, had previously held the record. The Cubiphora tibia pushes the behavior back nearly a million years further, deep into a period when the cognitive and social world of hominins was assumed to be far simpler. Species attribution for the bone remains contested. The morphology is consistent with early Homo, possibly Homo erectus, but the fragmentation prevents a definitive assignment. What is clear is that multiple hominin species coexisted in the Turkana Basin at this time. Homo erectus, Homo habilis, and Paranthropus boisei have all been recovered from overlapping layers at Cubiphora. The butchery may have been intraspecific, or it may have crossed species lines entirely. Caloric logic adds a layer of complexity. At 1.45 million years ago, the Turkana Basin was not a barren wasteland. Faunal assemblages from the same deposits include hippo, crocodile, antelope, and equid remains, all showing butchery marks. Large mammals were available. Targeting another hominin for calories when megafauna were present is, from a purely energetic standpoint, an unusual choice. But hominin bodies carry dense concentrations of fat in the brain and marrow, and the butchery evidence shows exactly those tissues were targeted. The same Cubiphora horizon has yielded some of the most important evidence of early Homo cognitive complexity. Refined Chilean hand axes, evidence of planned butchery sequences, and long-distance raw material transport suggesting forward planning and social coordination. These were not reflex-driven scavengers. That makes the cut-marked tibia more jarring, not less. The mainstream reading is nutritional processing, a hominin body encountered, possibly already dead, and systematically defleshed for food during a period of acute resource stress. Pobiner acknowledged that the evidence cannot distinguish between active predation, scavenging of the already dead, and ritualistic or conflict-related processing. All three scenarios produce the same damage signatures on bone. The most unsettling reading is that this was not scavenging at all. It was the aftermath of deliberate killing and interspecies competition for prey, territory, and water sources in a shrinking basin. One hominin group encountering another and treating the result no differently than a butchered antelope. We may have been doing this to each other not at the edge of extinction, but at the very beginning when the cognitive hardware for planning, cooperation, and tool use was first fully online. A hominin shin bone, 1.45 million years old, defleshed with stone tools, muscles stripped clean, and abandoned in the sediment, waits to tell us something about ourselves we weren't ready to hear. Top 4. The Goyet Cave Neanderthals. In 1867, geologist Edouard Dupont excavated Goyet Cave in the Samson River Valley of central Belgium. He recovered thousands of fragmented bones, cataloged them by site layer, and shipped the entire collection to the Royal Belgian Institute of Natural Sciences in Brussels. The bags entered storage and remained there for nearly 150 years. In 2016, paleoanthropologist Helene Rouillet of California State University Northridge began systematically re-examining the Goyet collection, originally to document Neanderthal population distribution across Western Europe. Instead, she immediately recognized a pattern she had seen before: stone tool cut marks, percussion notches, and deliberate bone modification concentrated across a set of human remains that had never been properly analyzed. Her methodology was rigorous. Her team re-examined 9 Neanderthal bone fragments from the collection and documented every surface mark under high magnification imaging. The marks were independently compared against reference databases of known butchery patterns derived from controlled animal defleshing experiments. Cut mark location, orientation, and depth were each recorded separately and cross-referenced against both tool use profiles and carnivore activity signatures to rule out non-human causes. Across the 9 fragments, the team identified unambiguous stone tool cut marks on bones from at least 5 individual Neanderthals, 3 adults, 1 adolescent, and 1 child. The cut marks were concentrated at major muscle attachment sites on femurs, tibias, and arm bones, consistent with systematic and deliberate defleshing. Several long bones displayed percussion notches, the specific fracture pattern produced when bone is struck repeatedly to extract the marrow inside. 4 Neanderthal bones had been further shaped into retouched tools and then discarded in the same sediment layer as the consumed remains. Published in October 2016 in Scientific Reports, the Goyet assemblage was initially interpreted as a standard mortuary deposit when DuPont first excavated it in the 19th century. Rouillet's reanalysis reclassified it entirely as a butchery and consumption site. That interpretive shift is the crux of the problem. If the processing was purely nutritional, it is cannibalism driven by caloric necessity. If the deliberate shaping of the bones into tools was intentional and structured, it implies something more considered and far harder to reduce to a single explanation. The cut marks and the tool shaping marks appear on different bones from different individuals, making unified intent impossible to confirm. Did the same group that consumed the flesh also manufacture the tools, or were these separate acts carried out at separate moments? Rouillet's interpretation is measured. The evidence most strongly supports nutritional cannibalism, but the presence of bone tools within the same deposit indicates the Neanderthals engaged with their dead in ways that do not collapse neatly into one motive. This makes Goyet Cave one of the most thoroughly documented cases of Neanderthal cannibalism ever recovered, involving a wider age range of individuals than any comparable site and showing a combination of consumption and tool production not previously recorded together. Guillem Genet of the University of Barcelona noted that because soft tissue decomposition leaves no skeletal trace whatsoever, every confirmed piece of cannibalism in the fossil record almost certainly represents a behavior far more common than the physical evidence can ever demonstrate. The bones sat in a Brussels storage room for 149 years before anyone counted the cut marks, and in a completely different corner of the fossil record, 1.45 million years earlier, in the dust of northwestern Kenya, a single shin bone sat in a museum drawer for 47 years, waiting for the same kind of attention. Top 5. The Tongue Child. The fossil known as the Tongue Child is the type specimen of Australopithecus africanus, the first early hominin ever discovered on the African continent, and the fossil that permanently shifted the search for human origins from Europe and Asia to Africa. It was unearthed in 1924 near Taung, South Africa, by quarry workers blasting through limestone, and brought to the attention of Raymond Dart, an anatomist at the University of the Witwatersrand. Dart named and described the species that same year, though the scientific establishment largely rejected him. The child died approximately 2.8 million years ago. What survives is a nearly complete facial skeleton, a natural endocast of the brain, and the lower jaw with milk teeth still in place. No body was found, only the head, alone in a cave deposit full of broken animal remains. It is just the head that matters. The Tongue Child stood roughly 1 meter tall at the time of death, weighed an estimated 10 to 13 kilograms, and had a brain approximately 1/3 the size of a modern human child of the same age. Based on dental development, it was between 3 and 4 years old. Despite being celebrated as a landmark of human evolution, this child was not a symbol of emerging intelligence or tool use. It was small, slow, and completely exposed. It lived in open woodland and savanna, exactly the habitat where large aerial predators hunt most effectively. It was not a pioneer of the human lineage, but a target. The interior of both eye sockets bear distinctive talon gouge marks, sharp, curved lacerations, consistent with a large raptor gripping the skull from above and behind. Comparative analysis matched the marks through their geometry, angle of entry, and positioning inside the orbital rim. Damage that occurs when a bird of prey drives its talons through the eyes to kill and immobilize prey. The base of the skull shows puncture damage and disarticulation patterns consistent with a raptor separating the head from the body at the neck, a feeding behavior documented in modern crowned eagles after carrying prey to a perch. The absence of any body bones in the deposit confirms the rest was never brought to the site. A study by Lee Berger and Ron Clark compared the Taung Child's orbital damage against skulls of monkeys killed by modern crowned eagles in South Africa. The correspondence was precise: identical talon entry points, identical depth profiles, and identical compression patterns around the orbit. The researchers concluded the match was not coincidental. The implication is straightforward but deeply uncomfortable. The town child was seized by a large bird of prey. The talons went through the eyes and the head was separated from the body. What was found in that cave was not a burial, it was the leftovers. Two scenarios fit the evidence. Either the child was killed outright, talons through the eyes, instant death, and the head was dropped near the cave, or it was carried alive to a feeding site and dismembered there. A 3-year-old hominin taken from the ground by something it never saw coming. None of the talon marks show any signs of healing, confirming the child did not survive the initial strike. The complete absence of body bones, no ribs, no limbs, no vertebrae anywhere in the deposit, is physical proof the head and body were separated before deposition. Something ate the rest elsewhere. The predator responsible was almost certainly an ancestor of Stephanoides coronatus, the crowned eagle, the only extant African raptor capable of taking prey the size of a small hominin. Adults of this species routinely carry prey exceeding their own body weight. The town child weighed 10 kilograms, while a large crowned eagle weighs up to 4.5 kilograms. The mainstream interpretation is opportunistic predation. A raptor encountered a small, isolated juvenile and took it. Some researchers favor a more targeted reading, suggesting that early hominins in open environments were a preferred prey type, hunted regularly rather than occasionally. And the most unsettling interpretation is that aerial predation was a primary selective pressure on early hominin evolution. That vigilance, group cohesion, and upright posture developed in part to watch the sky. A 3-year-old at the very beginning of what our species would eventually become was killed before it could react. New scientists describe the Tang child's death as one of the most poignant and disturbing cases in the entire fossil record. Yet the Tang child is displayed in museums as a symbol of human origins, a face behind glass labeled progress. That was 2.8 million years ago, death from the sky, and the victim was barely old enough to walk. Top 6, Homo habilis. OE7, not every predator needed speed or talons or size. Some simply waited in the water in the dark for our ancestors to come close enough, and they always did. The species name, Homo habilis, comes from Latin, homo meaning human, and habilis meaning able or skillful. The researchers who described the species in 1964 chose that name because the evidence of deliberate tool manufacture was unambiguous. Louis Leakey, Philip Tobias, and John Napier published the formal description based on fossils from Olduvai Gorge, Tanzania, the same site where Crocodilus anthropophagus had been hunting hominins 1.84 million years ago. The holotype specimen, cataloged as OH7, was discovered in 1960. Jonathan Leakey, 11 years old at the time, found the first fragment. The specimen includes a lower jaw, 13 hand bones, and partial skull fragments. It dates to approximately 1.75 million years ago. Estimated brain volume was originally assessed at 363 cc, roughly half the volume of a modern human brain, but it told a distinctly different story when reanalyzed in 2015. It was the first specimen ever placed in the genus Homo, beyond Homo erectus, more ancient than any previously recognized member of our lineage. Multiple anatomical features from the site, the precision grip geometry in the hand bones, the expanded brain case, and the associated Oldowan stone tools were attributed directly to this species. The designation was immediately and ferociously contested. Here is the critical detail. The 2015 reanalysis by Fred Spoor and colleagues found the reconstructed brain volume was dramatically larger than the original estimate, between 729 and 824 cc. But the mandible was simultaneously more primitive and more ape-like than anyone had previously recognized. That means OH7 is not a clean transitional form. It is a mosaic, more human in the skull, more ancient in the jaw. The tidy linear model of human evolution left no clean fossil to support it. The most unambiguous specimens told the most ambiguous story. The selective pressure was simple and inescapable. Hominins needed calories. Calories required butchering carcasses, which required tools, which required the fine motor control preserved directly in OH7's hand bones. The same Olduvai Gorge that preserved those hands also preserved crocodilian bite marks on hominin bone from this exact time horizon. These two species were operating in the same kill zone simultaneously. The related Homo rudolfensis, recovered from the Turkana Basin of Kenya, showed comparable cranial expansion under identical ecological conditions. Put this in modern terms. A hominin standing approximately 100 to 135 centimeters tall, weighing roughly 30 kg and with a brain half the volume of yours, was deliberately striking one rock against another to produce a sharp cutting edge inside an environment actively patrolled by 25-foot ambush predators. Modern child development requires years of fine motor refinement before intentional percussion becomes possible. 1.75 million years ago, a species we almost didn't classify as human was doing it routinely, and we nearly missed the evidence entirely because an 11-year-old picked up the right piece of bone. The mainstream interpretation is a cognitive threshold event. OH7 marks the approximate moment our lineage crossed from reactive to intentional behavior. Some researchers argue OH7 belongs outside the genus Homo entirely, that the mosaic anatomy makes it an evolutionary outlier rather than a direct ancestor. And the most speculative view is that the simultaneous presence of expanded neural tissue, precision grip, and stone tools at Olduvai represents not a transition, but a feedback loop. Tools shaped the hand shaped the brain, and the brain demanded better tools. OH7 is the fossil record catching that loop mid-cycle. A cognitive feedback loop may have literally constructed the human brain by making stupidity too expensive to survive. Scientists examined the totality of the evidence and concluded the most accurate name they could give this animal was literally the able one. And yet the next entry shows that ability alone was not sufficient. By 145 million years ago, Homo habilis was gone, and something larger and more dangerous had taken its place. Top 7. The Allosaurus impaled through the crotch. Allosaurus fragilis was a large allosaurid theropod from the late Jurassic of North America, approximately 155 to 145 million years ago, decades before the ecosystem that would eventually produce T-Rex. Adults reached 9 to 12 meters long and up to 2 tons, with a skull built not to crush, but to hatchet. It had blade-like serrated teeth, binocular forward-facing vision, and powerful hind limbs engineered for explosive bursts of speed. It was the undisputed apex predator of the Morrison Formation, and one of them died from a spike through the pelvis. The Morrison Formation was not a peaceful ecosystem. It was a seasonal, resource-competitive killing floor. It was a vast floodplain stretching across what is now the American West, shared between 30-ton sauropods, heavily armored herbivores, and multiple species of large predatory theropods. That competitive pressure meant Allosaurus didn't hunt passive prey. It hunted things that were actively trying to kill it back. The primary evidence of this specific wound comes from an Allosaurus pubic bone, bearing a puncture mark that precisely matches the diameter, shape, and angle of a Stegosaurus thagomizer spike. No other animal in the Morrison could have produced it. Robert Backer documented this specimen in a landmark study that reframed how paleontologists understood predator-prey dynamics in the Jurassic. It was the first confirmed case of large prey successfully delivering a penetrating wound to an apex predator in the fossil record. The puncture is located on the pubic boot, a bony extension near the base of the pelvis, anatomically close to the groin. Crucially, the bone shows signs of healing and regrowth around the wound margin. This is not a post-mortem scrape or a scavenging mark. The Allosaurus survived the initial impalement. It walked away from a Stegosaurus spike through its crotch and lived long enough for the bone to begin repairing itself. The Morrison's late Jurassic environment was dominated by some of the largest animals to ever walk the earth. Sauropods like Brachiosaurus and Camarasaurus lived alongside heavily armored herbivores like Stegosaurus, whose tail-mounted thagomizer spikes reached 60 to 90 centimeters in length and were driven by powerful muscular tail sweeps capable of generating enormous force. Allosaurus preyed on both. Its skull was adapted for a distinctive hatchet-style attack, raising the upper jaw and driving it downward into soft tissue rather than the bone-crushing bite of later theropods. That strategy targeted blood loss over brute takedown. It required the predator to get close, stay close, and absorb whatever the prey delivered in return. The mainstream reading is a failed attack. An Allosaurus lunged at a Stegosaurus, misjudged the arc of the tail during the struggle, and took a spike to the pelvis before breaking off the hunt. An alternative view is that the wound happened mid-contact. The Allosaurus was already locked onto the Stegosaurus when the tail connected, meaning it may have continued attacking while impaled or been momentarily pinned by its own prey before pulling free. The most speculative reading is that this fossil is not an anomaly, but a window, that Allosaurus hunts were not the clean, dominant takedowns we reconstruct in museum dioramas, but brutal mutual exchanges where the predator routinely left a hunt as damaged as the animal it was trying to kill. It was a system not of dominance, but of attrition. An apex predator with a spike through the pelvis somehow survived, a fossil record that proves the hunter bled just as reliably as the hunted. And in the same rock formation, paleontologists would later excavate another Allosaurus, this one nicknamed Big Al, whose skeleton told a grimmer story still. Top 8. Crocodylus anthropophagus. The fossil record of this species was formally described and named in 2010 by paleontologists Christopher Brochu and Jackson Niao. It is the defining specimen of a giant extinct crocodilian, the original evidence used to establish an entirely new species. Its remains were recovered from Olduvai Gorge, Tanzania, the same site, the same sediment layers, and the same killing ground where the earliest members of our genus were trying to survive. The fossils are approximately 1.84 million years old. What survives of this animal is a collection of skull fragments, jawbones, osteoderms, and limb elements. A concentration of hominin bones bearing distinctive pit marks and scoring was found within the same depositional layer and attributed to this animal's feeding activity. Crocodylus anthropophagus reached an estimated 7.5 meters in length, roughly 24 feet. It outmassed the modern Nile crocodile by a significant margin. Despite being classified as a crocodilian, this was not the opportunistic ambush predator of modern safari footage. This was a sustained, permanent presence in the same ecosystem our ancestors were trying to survive in. Not a background animal, but a fixture. Hominin bones recovered from Olduvai Gorge bear puncture marks, furrows, and scoring that closely matched the feeding traces of modern crocodilians preying on large mammals. Comparative analysis identified the marks through their circular cross-section, wide spacing, and depth consistent with large conical teeth under extreme bite force. Several specimens show evidence of body rotation, the characteristic death roll, inferred from the directionality and clustering of damage on long bones. A 2010 study by Niao and Blumenschein systematically compared the patterns against modern crocodile feeding experiments on similar-sized prey. All comparisons pointed to a crocodilian of significant size as the primary agent. The marks were not incidental. They were feeding traces, systematic, repeated, and complete. The implication is straightforward but deeply uncomfortable. Crocodylus anthropophagus was not a background element in the Olduvai ecosystem. It was actively consuming hominins, either ambushing individuals at the water's edge, scavenging carcasses already brought down by other predators, or both, across thousands of generations. It was a prehistoric toll on every individual that needed to drink. None of the affected bones show any healing response, confirming these were fatal or post-mortem events. The concentration of hominin remains within crocodile feeding zones is physical proof that the water itself was a kill site. Crocodylus anthropophagus shared its range with Paranthropus boisei and early Homo, both confirmed in the same sediment layers. The modern Nile crocodile, its closest living relative, kills an estimated 1,000 humans per year at a fraction of this animal's size. The mainstream interpretation is opportunistic predation at water sources. Some researchers argue for active pursuit into shallow margins. And the most unsettling reading is that hominins in this region faced a functioning gauntlet. ground predators on the plains, and a 7.5-meter crocodile at every water source, with no physiological defense against either. Some of the earliest members of our genus were killed and consumed at the water they could not survive without. Yet the standard depiction of early Pleistocene Africa frames hominins as toolmakers in transition, species moving steadily toward dominance. That framing required something to edit out. That was 1.84 million years ago. One predator from the land, one from the water. But the killing of our ancestors did not always require teeth or ambush. Sometimes the danger came from something far smaller, and the victim was not yet old enough to have ever stood upright. Top 9. The triple death of Edmontosaurus specimen. Mr. 1125 was a subadult Edmontosaurus annectens, a large hadrosaur from the Hell Creek Formation of Montana, approximately 66 million years old. The final geological heartbeat before the asteroid impact erased everything. Adults of this species reached 9 to 13 meters in length and up to 4,000 kilograms, built for endurance movement across open floodplains. They were herbivorous, social, and migratory, by every measure a successful animal. And yet this particular individual did not die once. It died 3 times. Each death was layered into the bone, each one readable 66 million years later. It is the most violent biography ever written in stone. The Hell Creek Formation is already the most death-saturated fossil environment on Earth, the last functioning ecosystem before the Chicxulub impactor ended the Cretaceous entirely. But what makes this specimen extraordinary is not the violence. It is the sequence. The evidence preserved in Mr. 1125 is not ambiguous or coincidental. It is a documented chain. 3 distinct biological events and 3 separate sets of physical trauma are all readable in stratigraphic order on one skeleton. 1 animal, 3 predators. Each one left a signature in the bone that can be distinguished from the others by depth, angle, healing response, and biological context. There was no contamination and no mixing. It is a record so precise it functions less like paleontology and more like forensic pathology. Kenneth Carpenter and colleagues documented the trauma pattern across the specimen in a detailed taphonomic analysis. It was among the first confirmed cases of sequential multi-event predation recorded on a single large vertebrate fossil from the Hell Creek assemblage. The evidence unfolds in order. First, healed stress fractures along the left femur with visible periosteal bone remodeling, meaning the injury occurred weeks or months before death. The animal had survived it and continued walking on a compromised leg. Second, deep scored theropod bite marks were gouged into the ribs and ilium with V-shaped cross-sections consistent with Tyrannosaurus rex dentition, indicating active predation on a living or recently killed animal, not passive scavenging. Third, a shallower secondary set of tooth marks from a smaller theropod was positioned on bones already partially stripped, consistent with post-abandonment access by a mid-tier carnivore after the apex predator had fed and left. 3 events, all distinguishable by healing stage, mark depth and predator identity. None accidental. The late Cretaceous Hell Creek environment was a low-lying coastal floodplain along the western interior seaway, seasonally inundated and seasonally arid, with resource availability swinging between abundance and scarcity. Large hadrosaurs like Edmontosaurus represented the primary caloric resource for an entire predator guild competing for the same prey. A subadult moving with a chronic leg injury across open ground was not simply vulnerable, it was a signal broadcasting weakness across a landscape patrolled by the largest terrestrial predator in Earth's history. The injury that preceded the death likely slowed the animal enough to make an otherwise difficult hunt a certainty. Its skeleton was adapted for speed and group movement. Alone, injured, and on flat ground, it had no remaining option. The mainstream reading is straightforward sequential predation and scavenging. Tyrannosaurus, when made the kill, fed to partial satisfaction, and abandoned the carcass, which was then accessed by a smaller theropod in a routine predator-scavenger hierarchy. An alternative reading is active competitive displacement. The secondary predator did not wait for the carcass to be abandoned, but approached while the apex predator was still present, triggering a confrontation that forced the larger animal off the kill. The most speculative reading is that the three deaths are not three separate events at all, but one continuous process. That an animal already broken by chronic injury experienced its final hours as a single unbroken sequence of being found, being killed, and being consumed in layers. What the fossil records is not three predators, but one animal's complete expenditure by an ecosystem that had already reclassified it as a resource. Top 10. Majungasaurus cannibalism. The Mayavarano Formation of northwestern Madagascar is among the most important fossil sites on Earth, famous for preserving a complete late Cretaceous ecosystem and abelosaurid theropods found nowhere else. It is also famous for a single set of bite marks that prove for the first time in the dinosaur record that an apex predator was systematically eating itself. This occurred during the late Cretaceous period, approximately 70 million years ago. The first animal is Majungasaurus crenatissimus, a stocky, powerful theropod, approximately 6 to 7 meters long, with a short, wide skull, a small dome-like horn above the eyes, and rows of serrated teeth engineered for gripping and tearing flesh. The second animal is also Majungasaurus crenatissimus. Same species, same teeth, same size class, same predator, different role. The reconstructed sequence goes like this. A Majungasaurus dies, cause unknown. A second Majungasaurus locates the carcass. It approaches and bites into the limb bones with full predatory force. It strips the flesh. It drags its teeth across the bone surface in long, deliberate scores. It moves methodically, femur first, then tibia, then vertebrae, working the carcass the way it would work any prey animal. The bite radius matches exactly. The tooth spacing matches exactly. There is no ambiguity about who left the marks. The feeder and the fed upon are the same animal. Both die eventually in separate events in the same formation. Their bones settle into the floodplain sediments of the Maivarano, where Madagascar's seasonal dry conditions, slow decomposition, and preserve bone surface detail at enough resolution to capture individual tooth drag marks. This is one of the only confirmed cases of repeated, non-opportunistic dinosaur cannibalism, supported by direct skeletal evidence across multiple individuals at multiple sites. Majungasaurus tooth marks appear on Majungasaurus bones throughout the formation, not once or twice, but consistently enough to establish a pattern. The bite force, tooth curvature, and spacing of the marks rule out every other large predator present in the ecosystem. Nothing else in late Cretaceous Madagascar had the dental geometry to produce these scores. The evidence does not point to an unknown predator. It points back to Majungasaurus itself. The mainstream reading is opportunistic cannibalism, Majungasaurus scavenging already dead members of its own species during periods of resource stress. Some researchers have questioned whether this reflects active predation on living individuals rather than post-mortem scavenging, but the absence of defensive trauma on the consumed bones argues against active hunting. There are no signs of struggle and no peri-mortem fractures consistent with a fight. This looks like methodical processing of a carcass, not a kill. The most speculative interpretation is that cannibalism was a seasonal behavioral strategy structurally embedded in Majungasaurus, survival during Madagascar's harsh dry seasons, when prey populations collapsed and the most reliably available large protein source was members of its own species. The predator and the prey were not different animals. They were the same animal, processed with the same tools, discarded in the same pile as any other meal, and preserved for 70 million years. The Cretaceous was not a world where violence followed clean lines between species. It crossed them, inverted them, and turned them inward. While Majungasaurus directed its killing efficiency toward its own kind, some of the most sophisticated predation strategies in the entire fossil record required no teeth at all, no claws, no speed, and no brute force, only patience and a trap that had been quietly evolving for millions of years. If these accounts of ancient survival and the harsh realities of the fossil record have changed the way you look at the history of life on Earth, please subscribe and like the channel. We are unearthing the history they tried to bury. Plant the seeds of the future. The next treasury of secrets will be revealed soon.